So hello guys, today we are going to see structural mechanics study of Stent using COMSOL software. So as we know that the COMSOL software is a multiphysics software which usually very helpful in performing any analysis of particular design. So today's we are going to see the analysis of the Stent. So this is the Stent, okay, which is the standard design, okay. And what we are doing, we are just taking single part of the Stent to perform structural mechanics in COMSOL software. So we have just taken this single part from this area, as you can see in this image, okay. So for performing the structural mechanics in COMSOL software, we need boundary condition. So what are the boundary conditions we are going to use? So there are two boundary conditions which we are going to use. First one is deployment pressure. So we have just taken three different pressure, 14 atm, 15 atm and 16 atm, which is like applied at the inner wall of the Stent. And secondly, we have taken 780 kilopascal pressure, which is applied on the outer wall of the Stent, which usually occurs by the plaque buildup. And so for performing the structural mechanics, we need material property, okay. So we are just taking material 316 LSS. So this is the density like 7850 kilogram per meter cube, and this is the modulus of elasticity, which is nothing but 193 gigapascal, and the Poisson ratio is like 0.226, and this is the massing, as you can see in the image. So massing divides whole structure into the small elements. So what happens on the small elements, a particular equation solves like by the software. So that's how we gets results, okay. Computing the results, we got these results. So this is the von Mises stress at 14 atm deployment pressure. So we got 387.10 to the power 8 pascal stress, and for 15 atm deployment pressure we got 4.49 10 to the power 8 pascal, and for 16 atm deployment pressure we got 5.1 10 to the power 8 pascal. These are the like maximum stress which we got after performing this structural mechanics study in COMSOL software. So now we will gonna like solve this particular study in COMSOL software. So this is the design of single part of the Stent which we have made in SolidWorks, then we have just imported in COMSOL software. So first of all, we have to define the parameters. So in the parameter section, just type all these things like load will be the 14 atm, okay, and this is the Young modulus, and this is the pressure which is actually applied on the outer wall, okay. And then we have to just click on linear elastic material property, and so here we have to define the material property. So the solid model will be the isotropic, and then in the Young's modulus section just click on user defined and type Young's modulus, because we have just defined in the parameters, as you can see. And for Poisson ratio just write 0.3, and for density just write 9100, okay. Then for applying the boundary load, just right select on solid mechanics, then you can see the boundary load, just select on it, and this is the boundary load. And applying boundary load, we have just selected the bottom of the design, and then we have just taken fixed constraint. For fixed constraint, we have just selected this face and this face, as you can see. And for outer wall pressure, we have just selected the boundary load 2 and selected the upper part of the Stent. Then we have done massing extremely fine, you can see here. And for computing the result, just click on compute. Okay, so this is the von Mises stress for 14 atm pressure. Okay, if we want to see the von Mises stress for 15 atm, then we have to just change the value in the parameters. Just click and write 15 atm, and then just click on study and then compute. Okay, so yeah, this is the von Mises stress for 15 atm pressure. And if we want to see the von Mises stress for 16 atm, just write it here and study and then compute. So yeah, this is the von Mises stress for 16 atm.